So let's start now. And so welcome to the MENA CSV KIP webinar, Concentrated Solar Heat Lessons Learned in Mexico. So today our two experts, Angel Mejia and Pedro Horta, will share some of the lessons learned in installing concentrated solar heat for industrial processes in Mexico, and how those lessons could be transferred to other geographies, including the MENA region. So without further ado, please, Pedro, start with your presentation, please.
Sure, I will. Good afternoon, everyone. First of all, thank you so much for your interest and for attending this webinar. Thank you so much for ITA Insight for the invitation. And well, I will just start my presentation by sharing the screen. So I guess you can see my presentation.
Yes.
So my presentation is based on recent experiences I had on this topic, concentrating solar heat in both Mexico and Jordan. And I would like to make a comparison between these two different contexts. Before going into the contents, lessons learned, and my insight is that definitely Mexico presents an interesting context for these kind of applications. So first of all, I would like to look into DNI resource, which is the fuel we are using when using concentrating solar heat. And when we compare the resource we find in Jordan with the resource we find in Mexico, we see that they are very alike. So in Mexico, especially the central and north region, presenting rather high values, even higher to those we might find in Jordan. And so definitely on that regard, both countries present very interesting, not to say more, the solar resource potentials. Then one other important aspect has to do with, of course, the available technologies, but also with the potential we might find in the different industrial sectors we find in each of these countries. So in regard to technologies, and I believe the available technologies are known, at least to most of the attendees, but basically, as of today, there are commercially available technologies enabling the production of heat up to 400, 450 degrees. So I would say that most commonly concentrated solar heat applications so far have been going up to 200 degrees. That does not mean that higher temperatures are not possible. They are possible and there are available solutions. But focusing only on this temperature level, so up to 200 degrees, which includes all the non-energy intensive sectors, for instance, textile, food and beverage, a very important sector, leather, machinery manufacturing, and so forth. If you look into the table on the right of these slides, you can see the value added in percentage of total manufacturing for different industrial sectors. And so this is a statistic information by NIDO. It's available online. And what we can see is that whereas in Jordan, we might find a potential for temperatures below 200 degrees, standing for about 51% of the total manufacturing value. That value for Mexico is even higher, and it's around 65%. So that shows us indeed that the sectors which could more easily be tackled as of today with these technologies represent rather important added value in the total manufacturing capacity in Mexico. So that gives us a good indication of a good market potential. On the other hand, and not going too deeply into investment assessment of particular projects, but what we can see in terms of competitiveness, and comparing to the study we at MENA KEEP CSP project did some months ago in regard to different countries and regions, including Jordan. I was comparing the evolution of prices of different fuels in Mexico, and this information is very recent, it's from October, so it's from this month. And with those we found in the Jordanian context, so namely natural gas and diesel. Because for these results, we have found already some interesting results in regard to competitiveness. And what we can see in Mexico is that, of course, there is an important divide in regard to fuel sources being replaced by concentrated solvents. So on one hand, we have combustion, we have liquefied natural gas and natural gas with rather low costs, so standing for costs below the natural gas costs we could find for Jordan as of today. But when it comes to GCP or diesel, especially diesel, the costs are actually even higher than those we find in Jordan. So this is a very important information, because of course the competitiveness of this technological solution will always depend on the energy source being substituted. And so if we look into the conclusions we found in the MENA KEEP CSP project in regard to Jordan, and of course in here we must look into the macroeconomic parameters used. What we could see was that for different values of solar resource, which you can find in here, we could see very clear that when we were replacing diesel and considering average technology costs as of today, the concentrated solar heat solutions seem to be competitive pretty much all over the territory. When it comes to natural gas, that is no longer the case. Of course, taking into consideration a critical capex level for a 5 years payback, which is well, a standard approach in industry, not the best approach in my opinion, but it's a standard approach with which we need to work in industry. Of course, these results depend very much on the expectations in regards to internal rate of return of these investments. So looking into what we might find as reported projects and reported on an international database, which is the Ship Plants Info database, maybe the most comprehensive database on concentrated solar heat and solar processing projects in general worldwide. We can see that in Jordan, we might identify already 3 projects standing for a total of 2,550 square meters installed. Being the largest of these projects, GTI, it's a tobacco manufacturing company in Jordan, with a total of 1,880 square meters of fennel collectors. And when we look into the same information in regard to Mexico, well, actually the situation is much more promising. We can find already 73 reported projects with a total installed solar collector area of more than 31,000 square meters, being the largest of the plants reported in the database. Copper mine in La Parena, using 6,270 square meters of flat plate collectors. So this is, to me, a good indication of the potential of this technological solution in Mexico. Adding to that, not in the presentation, but adding to that, my personal perspective of what I could see in Mexico. I see that the country gathers already very important resources in terms of awareness of the technology, and that there is public support for conducting energy audits and for using the technologies in the industrial context. So me personally, I would say that Mexico is actually one of the most promising countries worldwide in the present moment for the use of these technologies. So this is my brief presentation comparing these two countries. So I will be open for further discussions. You will have my contacts in the end of the presentation if you would like to discuss some other issues in this regard. And so please feel free to ask any questions. Thank you so much.
Thank you, Pedro, for your presentation. Very interesting. As you said, Pedro, and I'd like to encourage the audience who are being a bit shy today to share the questions through the Q&A box. So it's your chance to, we have the first question. So and I hope to see quite a few more. If you could stop sharing your presentation now, and then we'll give the floor to Angel to give his presentation.
Great, I'm ready now.
Okay, see the presentation is open screen and I can see it is working properly. So over to you, Angel.
Thank you, Carlos. Pedro, nice to share this webinar with you. I present myself. My name is Angel Mejia Santiago. I'm the CEO and co-founder of Inventive Power. And we're a Mexican company. My co-founder Aldo Agras and me, we co-founded the company about 8 years ago. The company started as a university project. We started developing concentrating solar technologies. So at the end, we see that there was a huge market on the industrial solar heat. So we start developing our technology. So now we have more than 40 people working with us at the company. And also we have a lot of R&D collaborations with national and international institutes, and also national government support in order to support our R&D development. And we have received several awards through the years that we have working on the company. Also, at the beginning of this year, we get our ISO certification of quality. So as a company, we have all our processes designed to attend any type of clients who wants to install a solar thermal project on their facilities. Great. So Pedro showed almost the same graph about the potential of the solar radiations that our country have. There's almost all the country have potential to install this type of concentrating technologies. Of course, the north of Mexico have really good radiations, but almost all Mexico is suitable to install any type of solar technology. So we are a very, very lucky country to have these resources available. I think so we need to work harder to take advantage of the resources as soon as possible. About last year, there was the development of a heat map in Mexico. So in this map, it was done from several governmental entities and also from the GIZ. And this map shows us where is the uh, the places in the country that consume more heat. So this map is very good for our market because we can see regions in Mexico where there's the most consumption of heat. And if we do some zoom on the map, we can see almost a very close look areas in a city where you can when you can see factories or different facilities who consume heat. So I think so this is a good tool that help us in order to see prospect for our technology. So, well, everybody knows that heat is in every day in our life. So there's almost all the products that we eat or the clothes that we use or the beverage that we drink, almost all products are made with heat. So heat is very important on a daily basis, and is important that this type of heat can be provided from a renewable source. Almost now, all the attention are focused just in electricity, renewable electricity, and also in the mobility area on cars and trucks. But industries and heat is a very important source of CO2 emissions that we have to tackle in order to prevent climate change. So in Mexico, there's a large market opportunity. There's more than 32,000 boilers, installers, and water heaters. There's a huge potential in this market. Well, as Pedro told us, there's a different type of industries that use very intensive use of heat. Okay, so our company developed two types of solar collectors. We have two models, PowerTruck 110 and PowerTruck 250. So we have a range of temperatures that we can provide with these collectors from 60 to 250 degrees Celsius. So these both products are very flexible to install on the rooftop areas of the factories or on the land on available areas in order to generate heat and consume directly in industrial processes. Everybody knows how this technology works. This is a parabolic trough collector that focuses the sunlight on the receiver. And we have our tracking system that is automatically. It has several features that prevent some type of failures like overheating in order to prevent any failure on the system on the collector. Of course, well, the thing is to how the more important challenge in this type of project is how you will integrate the collectors to the industrial processes. So I think so there is where the magic works, because you need to do a tailor-made project for each installation in order to integrate collectors with actual processes, and the process don't be disrupted for the use of the solar energy. So the process has to work as usual, and the process don't have to be aware of what type of energy is consuming. If it's consuming steam from the boiler or is consuming steam from the collector. So that's, I think, so the main challenge of this type of project. So as Pedro showed us in the example of Jordan, is that, solar thermal energy is the cheapest way to consume heat. In Mexico, is the cheapest way to consume heat. So of course, diesel is very expensive. We can see in this graph, even though compared to natural gas, if you do an LCOH analysis, you can see that even though solar energy is cheaper than natural gas, and natural gas prices in Mexico that are very low, because, well, Mexico don't produce natural gas, but we are next to the biggest market of natural gas, that is Texas. So all natural gas provided from Texas, and it's very, very cheap. But even though solar thermal energy is the cheapest way to consume heat. We have more than 100 projects installed in Mexico, more than 24 states. There's an examples of companies that we have been working here in Mexico. We can see some installations, some pictures. You can see more information on the chip plant web page. But there's many type of examples, like this plant in Nestlé that we heat water to feed some heat processes for the dairy plant, or this candy factory, they need heat in order to produce the candies, all these formulas. This project, Lechera Guadalajara Sello Rojo, the name is the brand of the company. We design solar pasteurization, so we connect directly the collectors to the pasteurization machine. So it was very challenging because pasteurization is a very, very delicate process. The temperatures has to be very, very precise. So this was a very big challenge. We did it. We connect the collectors with the pasteurization machine, and the process works perfectly. This is another example. This is one of the it's more from our Mexican industries. This is a Mezcal factory. So they to produce Mezcal, you need a lot of heat for distillation or fermentation processes. So we provide heat for this factory as well in Oaxaca. Also, we work with Jose Cuervo, that is one of the biggest tequila brands in the world. This is one of our newest project. This project is in a cheese factory. So we are installing this project to produce 3.5 tons of steam per day for the pasteurization process before the production of the cheese. So this also is a very challenging project because we are connecting the project with the main steam the main steam pipes of the factory. So we have to work a lot with automatization of this project in order to provide heat from solar or provide heat from the boiler, but always have the same pressure on the pipes of the steam pipes. So it's very, very challenging. I think like almost in 1 week, we're going to deliver this project to our customer. So there's a map of projects that we have installed from all over Mexico. So we are very focused now on the Mexican market. I think so Mexican market is huge. It's a very challenging to work here. But I think so market is it's very suitable for any company who wants to develop this type of projects. I think so we need more companies that can provide this type of installations in Mexico. We are very happy to work with any other type of company to try to develop more our market. As a company, we're looking to another market like Chile or some Caribbean islands as well, because there's huge potential there also. Just to finish, we sell our projects on different types. We sell projects directly to our clients as a tailor-made project, and also we sell to business representatives like other companies that work or know the engineering. We provide the product and they install the product as well with our support. And also we have a new type of sales that is to sell thermal energy. It's a heat purchase agreement that is like a heating as a service. So we invest on the solar plant and we sign a energy contract and we sell the thermal energy to our clients on an average 10-year contract. So we sell the thermal energy cheaper as they are paying now. Of course, we operate and maintains the project on all the time of the contract. So we are now closing our first deal with this type of agreements, and we are very excited to develop more of these business models on the next month. So great, guys. Thank you very much.
Thank you very much, Angel, for your presentation. So, as you can see, we've had quite a lot of questions, and I could see Pedro typing away, answering most of them. Thank you, Pedro. We'll take up some of them to be read out loud, and in particular, I'd like to focus on business models. So it seems that these, as both of you, Pedro, Angel, you have pointed out, there is a need for heat, which is greater than electric need, electric demand. Still, there is still a lack of. The industry is starting to realize that they could have a renewable option in solar energy. So it seems that one of the big obstacles is the fact that they would need to, in many cases, companies are reluctant to invest upfront. So what are the options that that companies have if they're not willing or able to put all the capex in one go to have a CSH project, or simply if they don't want to own the project outright, they just want to own the hit? Because I would say, it's the same with most operations. They don't really own the power generator. They buy electricity. So what are your thoughts on this, Angel? So out of the business models that you outlined there at the end, which one is the one that companies are going for? Angel, you're still mute.
Yeah, sorry. It's a very good question, because heat is a service. Companies see heat as a service. They pay a monthly bill to their gas or fuel company, and that's it. It's an OPEX. It's an operational expenses. So if you go there and you try to convert this OPEX to a capex investment, that's the challenge. So I think so. This type of business models that you convert this capex to an OPEX, is more easy to convince clients in order to accept these proposals. Also, clients there are not experts in solar energy. We have seen a lot of projects that sometimes clients don't look or don't take care of the maintenance of the equipment. because it's not their main purpose. Maybe their main purpose is to produce tequila, but not to take care of solar plant. So we have seen that it's very it's necessary that us as a company or another company have maintenance contract in order to maintain always the best the best performance of the solar plant. Yeah, if they own the product, it's more easy that they don't take care of the product. It's better if we do the service also to operate and maintain the plant. So yeah, but sometimes business is very good. Capex and return of investment is very quick. Clients prefer to pay upfront.
Okay, thank you very much. Pedro, I don't know if you'd like to add anything to what Angel said.
Yeah, sure. Well, looking to this question from the perspective of a researcher, trying to understand the dynamics of both the technologies, but also of the potential market. It seems to me that financing is a very critical question when it comes to process it. Typically, we are dealing with an investment which deserves an assessment in terms of net present value and not of payback period. If we are talking about thermoelectrical production, for instance, CSP, this is the approach of utilities. They look into net present value, not only to payback. So they are willing to take longer paybacks, regarded that in the end they have an interesting internal rate of return by the end of the project lifetime. But when it comes to small or even medium or large companies, investment assessment is always done via payback. And normally the first indication of a reasonable payback we get from industrial customers, in our experience, maybe I have has a different opinion, but I don't think it should be too different, is that they are willing to accept a payback period of up to 2 years. So it's very difficult, not to say impossible, to find such a scenario unless we are dealing with an energy source which is absolutely out of context, totally expensive. So we must have in mind that we are purchasing an equipment which is going to deliver the energy we are using for the next 20 years. So it's like you buying a car, but buying the gasoline you're going to use in that car for the next 20 years all at once. So of course, this requires a different approach to the investment assessment. So that's why I believe that this is a business which is very prone to a ESCO model, or there might even be different models. So Angel was talking about leasing, is also a possibility. And there is not much tradition into using these kind of models in this kind of application. So I was very happy to see Angel's presentation, because they are working on it, and to my advice, this is the right way to go for this application.
And you know, it makes a lot of sense. I think both Pedro and Angel have mentioned that, you know, this kind of model where you take the you assume, well, the heat producer assumes some of the risk, so the consumer doesn't have to shoulder all of its risk is ideal. But then, you know, I've seen a question here by Elena Cuadros, which I think is the one that I was going to ask next, which is, you know, when you, it says, Angel, when you sign a heat purchase agreement, do you take all the risk, or are you getting support from ESCOs, from financial institutions, from the government? How do you know, how is it possible for you to offer a heat purchase agreement? Or how do you manage the risk of offering a heat purchase agreement?
Okay. Yeah, can you hear me? Yes. So for a heat purchase agreement, well, of course, there's risks there. So you have to analyze very well how you're going to integrate the project to the actual industrial processes, because you need to be sure that the production of heat from the solar plant will have impact on the consumption of fuel of the company. And also you have to look for processes and industry that has to consume all the heat that you produce. You cannot install in a company that doesn't work 7 days a week, or that maybe have a stationary production. So you have to look about that. Also the risk is about the daily function of the plant. So you need to propose this type of business models for big projects in order that you have someone who operates the plants every day. So you have to pay for someone that will be always looking for the optimal performance of the plant, and you will you can have these expenses when you have a big thermal generation. So you have to do a very good maintenance and operational schedule. So in order that you get sure that you always will get the most energy from the plant.
Thank you, Angel. So what you have mentioned there is that you're literally looking at from the operational point of view and having the most optimal performance so you can secure your return. Would you say that's fair?
Yeah.
You know, and this ties into a question that was asked early on, which is about the performance issues that you might find in a project of this kind. It was asked by Fred Morse, who is a man with many years of experience in using CSP in the power sector and developing CSP plants. And you know, he knows the power sector very well, but the CSH sector has its own challenges. So what kind of performance issues do you have to look out for when you look at a CSH project?
Well, of course, as solar thermal technology, any type of technology, of course, you have any issues you have to tackle every day in order to make sure the plants work perfectly. These type of technologies are not standalone. You have to take care of them because it's a product that generates hot water. So you will have problems with the piping, that you have some instructions inside the pipes. So you have to clean pipes every certain time. It depends on the quality of the water. So you have to take care of what type of water go inside your collectors to prevent that also. Also, one of the main problems for this type of technology are the overheating. So you need to have different type of equipment that prevents overheating. One of our main advantage of our product is that if you want to stop taking solar radiations, you can take your collector out of the focus. So our collector have like a thermal, like a temperature sensor, a thermometer that if the temperature is above a certain temperature, collector will go out of the focus. So this type of features you have to have in order to prevent failures in the system.
Thank you, Angel, for your answer. Very comprehensive. Pedro, I don't know if in your experience as a researcher, you have come across any particular snags that you have to look at to make sure that the operation of these systems is optimal.
Sorry, I could not really understand that part of your question. If I have
the question is just going back to the question we asked Angel about the main operational issues that you might find. So, what are there any aspects that you would recommend looking out for in terms of the ensuring the optimal operation of a CSH system?
Yeah, well, definitely soiling, dusting of the collectors is one issue. So depending on the site, we might need to take a look into the aspect of the mirrors, because of course, as the mirrors start to get soiled, the optical performance of the system will become lower. So this is one aspect, but it's not a very complicated one. Another important question is to look into all the control systems, especially in direct steam generation systems. Of course, it's important to assure that the system is being operated in such a condition that assures good steam quality at the system outlet. On the other hand, I would say normal maintenance of valves every 6 months would be recommended. But on that regard, I don't see larger requirements than those we already have for steam boilers. So I would say that in terms of maintenance and operation, the solar system, so besides the control, which is very specific, especially if we are concentrating solar heat, besides that, I would say the maintenance required for a solar system does not differ too much from that we should have on a conventional boiler.
Okay, makes a lot of sense. You know, they would be quite like well-known and relatively straightforward systems to maintain. There's a question here on the importance of solar resources on bankability. So the question reads, how important is the quality of DNI data for CSH projects in terms of bankability? Is it needed? Is a measurement campaign needed? So what do you do in these cases? Angel, do you spend some time measuring direct solar irradiation?
Well, no. For this type of project that are not so big, we are based on available data. We can base our calculations from available tables of radiations. I don't know, from NASA or different type of sources. There's some parts of Mexico or countries that also have national measurements of radiations available. So we work with these data. Sometimes we do some preventions, or we are sometimes conservative with that data as well, in order to make sure that the performance of the project will work as we want or we designed. But for bankability, as this type of projects are also not so big, almost all projects are not so big in capital. Most of banks or finance institute, they look more for, they are sometimes not look a lot on this type of technical information in order to approve a finance. They look more for the finance numbers of the company. if numbers are good in the company, if they can give to them a finance. It's more about that. It's more about the company financial situation in order to approve a finance to them.
Okay. There is a question here, like moving on more onto the regulatory aspect. Do you think that there is a role for government or other institutions in promoting this technology?
Is there another companies?
Is there a role that governments or other institutions could play in furthering the use of concentrating solar heat?
Well, yeah, Mexico, there's some governmental institutions that want to promote this type of technology. They prepare some market reports, see the potential of this technology on the market and how this technology can help to reduce CO2 emissions. But just that, a couple of years ago, there was our energy reform here in country, and in almost in all the pages of these documents, they don't mention even one time the word heat. So for government, heat are okay. They are looking to promote some market reports, but there are not any type of policy to develop this market in Mexico. So I think so for now. We have to work more with the market conditions of fossil fuel prices, how we can reduce the price of our projects in order to companies be more interested in this type of technology.
Maybe I could add to that. That working maybe a bit closer than Angel coming from a company, working with recommendations to public policies. It is true that generally speaking, when people talk about energy, what comes to their mind is a light bulb, is electricity. And there is very often a confusion between electricity and energy, which is even in policy documents, which is not very prone to make clear the importance of processes. For you to have an idea, worldwide, in terms of final energy consumption, processing stands for more final energy consumption than the whole electricity market. So in terms of potential impacts regarding decarbonization, for instance, definitely something to be considered. And I would say in some countries more than in others, it becomes clear that the decarbonization of the industrial sector needs to go through the decarbonization of its supply. So in industry in general, 2/3 of the energy consumption is related to heat and only 1/3 to electricity. So definitely this is something we need to take a look at. So I believe that in different countries which are today developing decarbonization strategies, that's the case in Portugal, but also the case in Mexico, for instance. There are targets to be achieved in terms of emission reductions. These targets can be set even for different sectors, so isolating industry as well. But then when it comes to specific measures to decarbonize these sectors, that's when it becomes sometimes a bit more tricky to make it visible, the potential impact of solar processing. So I guess it's not an easy task, but definitely it's important that the general public becomes aware of the potential of these technologies and how they can solve the decarbonization challenges faced by industry.
Thank you very much, Pedro Angel, for your answers. I think we have time for one more question, and I'd like to say, we have been mostly talking about challenges, but I think that in relative terms, I'd say that Mexico is, we could say, is a success story. There have been, more than 70 projects in Mexico, which is more than in most other countries. So, in your opinion, Angel, why do you think that this is the case? What have been the main factors that have driven the adoption of solar heat systems in Mexico?
Yeah, well, of course, one of the main reasons are fossil fuel. Well, one is fossil fuels prices. Mexico is not a very it has not developed yet all the pipelines to deliver natural gas to most of the areas of the country. So there's a lot of places in Mexico that they have to use diesel or LPG gas. So of course, these type of companies are our main targets here in Mexico. Also, well, we develop a technology that are very competitive with these in the markets or prices. We try to do projects that are with the best cost benefit ratio. So our payback period are very, very interesting for companies, and makes that with their savings, they can pay for a finance or a leasing. So that was our challenge, that if they get a 5-year leasing, they can pay the leasing with the savings. So we almost in our projects try to do this match. So we try to convince clients that if they do the project or they don't do the project, they will remain paying the same amount of money in a monthly basis. So it's like sometimes you can tell that it's a no-brainer decisions, but it's not that easy as it sounds. You need to have a lot of confidence with clients. It's very challenging because if you go to a factory and you talk with the owner of the company, 95% of these owners, they don't know that they can produce steam or heat with the sun. So you have to educate first the client and then convince that the technology is working already in another facility. Sometimes you take the clients to visit another client's facility, and then you propose a very good finance technical proposal in order to close a deal. Also, this is a heat rate radio, so you have to see how's your heat rate, and if you have a heat rate of, I don't know, 10% of heat rate, so we have to visit 10 companies in order to close one deal. So many companies don't look for this type of market or marketing statistics. So you have to do a lot of work daily, and you have to have always a lot of prospects open in order to close one deal. So we work on that every day.
So just to close, really, what would you tell very quickly a potential, an industrial user who might be watching us now, who is hesitant to try these systems, to get them more interested in the technology?
I think so. I will tell to them that there's a lot of business cases now that companies that are working. We are very, very happy to have a visiting of these companies, take them to see actual installation, how it works. And we have everything prepare to that the clients have the confidence to install this type of technology. Also, like in our contract, we have like a heating like insurance that we not just sell product, we sell the performance of a product. So if we don't deliver the performance, then we have to invest more on our own costs in order to get to this performance. So this type of contract is good for clients to have the confidence to do this type, to install this type of technology.
Very good. Thank you very much, Angel. So, well, you know, it's been great to have both of you today. I'd like to thank the members of the audience as well for sticking with us for the full hour. Any final words for the audience, Pedro?
Well, thank you for your interest, and hopefully you will take a better look into the possibilities of these technologies for industrial applications.
Thank you, Pedro. Angel, any parting words?
Thank you very much for everyone. You can look on our website for more information. I'm available on my email also for further questions, information that you want to have from our projects or technology. We are open to talk, and also any type of companies that want to promote this type of technology to promote our project or products. You can also send me an email and I can send you also information.
Thank you, Angel. And finally, I'd like to thank the the World Bank's MENA CSP Kit program for making this webinar possible. And I'd like to remind you that we have another webinar coming up on concentrated solar heat, which is called Bringing Industrial Solar Heat to Market. You can find it in the chat box, so it's just there now. And well, without further I do really think it's time to close the webinar. Thank you very much, all of you, for being here, and see you here next time.